A tree, or prefix tree, is a tree where each edge is labeled with a character. A path from the root spells a string. We mark some nodes as end of word. Tries are used for autocomplete, word search puzzles, and prefix lookups. We start at the root. Inserting cat, we add edges for C, A, and T, then mark the final node as end of word. Inserting car, the edges C and A already exist, so we reuse them and only add R. The path C, A is shared by both words. That shared prefix is exactly what makes a tree memory efficient. Each node stores a mapping from character to child node, and a boolean indicating whether this node marks the end of a word. The root has no incoming edge, the path from the root spells the prefix. To insert a word, start at the root and follow edges for each character. If an edge does not exist, create a new node. At the end of the word, mark that node as end of word. We insert car, then cat reuses C and A and adds T, care reuses C, A and adds R, E. To search for a word, walk from the root following one character at a time, lighting up each node we visit. If we cannot follow an edge, the word is not in the tree. When we finish the word, check whether this node is marked end of word. For car we follow C, A, R and reach a node marked end of word, the word is in the tree. For CA we follow C and A, but that node is not marked end of word, CA is only a prefix, not a stored word. Starts with checks whether any stored word has the given prefix. We walk the tree character by character, lighting up each visited node. If we reach the node at the end of the prefix, the answer is true, no end of word check needed. For the prefix CA, we follow C and A and successfully reach a node, so yes. For CO, we follow C but there is no edge for O, so no word has this prefix. This is exactly how Word Search 2 uses a tree. During DFS on the board we ask whether the current path is a prefix of any word, and prune early if not. L is the length of the word or prefix. Insert, search, and starts with all run in O of L, one step per character, following or creating edges. Building the entire tree from a set of words takes O of n total, where n is the sum of all word lengths. Space is also O of n, every character needs one node, but shared prefixes mean common parts are stored only once. Class node, each node in the tree has this structure. Children, a map from character to child node. Is end, boolean, true when this node marks the end of a word. Insert, we add a word to the tree. Start at the root. For each character in the word. If that character is not already a child, create a new node. Assign the new node to children of C. Move current node to that child. After processing all characters, mark the node as end of word. Search, return true if the word is in the tree. Start at the root. For each character in the word. If the character is not a child, the word is not in the tree. Return false. Else we have a child for that character. Move to that child. After the loop, return whether this node is marked end of word. Starts with, return true if any stored word has this prefix. Start at the root. For each character in the prefix. If the character is not a child, no word has this prefix. Return false. Else move to that child. Advance node to the child. We reach the end of the prefix, return true.